Welcome to the United States Sports Academy, America's Sports University. This is Unit 3 of Math 465. Statistical Measurements in Sports. This unit presents methods of calculating percentiles and covers the measures of central tendency. It is important to note that this presentation is simply a summary of the topics covered in Unit 3 and not intended to replace the textbook or any supplemental readings.
Welcome to Unit 3 of Statistical Measurements in Sports. This unit focuses on calculating percentiles and understanding the measures of central tendency. The first thing that you'll learn in this unit is how to calculate percentiles. Percentiles are very helpful in interpreting data, especially when it comes to the teaching and the sports professions. Another important thing that you'll learn in this unit is how to calculate the measures of central tendency, such as the mean, the median, and the mode. One of your objectives for this unit is to calculate the mean, median, and mode of a particular data set. Now, an easy way of doing that is using the data analysis packet in Microsoft Excel and running descriptive statistics on the data set. Descriptive statistics provides basic features of the data set and are very helpful in helping to summarize the data. So, calculating percentiles and running descriptive statistics are the main objectives that you want to learn in this unit. If you have any questions, please contact your instructor. Thank you.
After successfully completing this unit, you should be able to 1. Determine percentile scores from ranked order data. 2. Determine percentile scores from single frequency data. 3. Determine percentile scores from grouped frequency data. 4. Understand common percentile divisions. 5. Calculate measures of central tendency such as mean, median, and mode. Percentiles are probably the most common statistical tool and are helpful in interpreting data for the lay public. In statistics, a percentile is defined as a point or position on a continuous scale of 100 theoretical divisions such that a certain fraction of the population of raw scores lies at or below that point. The figure shows a graph of the number of sit-ups performed in 1 minute by 1,000 7th grade boys. Both the raw scores, indicated by the number of sit-ups, and the percentile divisions have been plotted. You can see that 30 sit-ups is equal to the 50th percentile. Slide 6, Quartiles and Deciles. Two of the most common ranges of percentile scores are the quartile range and the decile range. The quartile range is divided into 4 equal parts, while the decile range is divided into 10 parts. The figure shows the quartile and decile divisions of the percentile scale.
For this lecture, I'm going to be talking about organizing data into percentiles and quartiles. But first of all, I want to talk about percentages. Imagine we have a data set like this, very simple, 1, 2, 3, 4, and 5. I could ask you a question like, how many numbers are even? Well, it's pretty obvious. The 2 and the 4 are even. But we could make that into a percentage. A percentage is basically the number of things meeting the characteristic of interest divided by the total number of observations times 100. So that might sound kind of weird, but let me show you this. The characteristic of interest is even. There are 2 even numbers divided by 5 total observations. So 2 divided by 5 times 100 is 40. We could say that 40% of the numbers in this data set are even, and that would be a percentage. Now, a percentile is a value below which a certain percentage of the observations lie. So let me show you what that means. Here's a longer data set. It goes from 2, 2, 3, all the way up to 11, 12. Now I could ask you, what is a percentile ranking of 10? So we have 10, and basically I want to know what percentage of scores lie below that. So all these things that I have here in blue are scores that are below 10. So for the question of what is percentile ranking of 10, we can use this equation. The percentile ranking of any value is equal to the number of values below that value divided by the total number of values in the set times 100. So there are 16 blue numbers below 10, and there are 20 total numbers. So 16 divided by 10 times 100 is 80%. The percentile rank of the value 10 is 80% because 80% of the scores lie below it. So now we can kind of work backwards. What value exists at the percentile ranking of 25%? So we're asking basically what score has 25% of the scores below it. So we can use this equation to find out what value number is basically the percentile divided by 100s multiplied by the sample size plus 1. So we're interested in the 25th percentile, so I do 25 divided by 100 times 20 plus 1 because we have 20 scores. And when I work all that out, I get a value of 5.25. But that doesn't really make any sense. I mean, there could be a fifth value or a sixth value, but there is no 5.25th value. So if you end up with something like that that isn't a whole number, you can just take the average of, in this case, the fifth and the sixth. And whatever that average is, that is what exists at the 25th percentile. So my fifth number is 5 and my sixth number is 5. So the average of those two numbers, the mean of those two numbers is obviously 5. So for the question, what value exists at the percentile ranking of 25%, the answer is 5. Now one more quick thing, quartiles is pretty simple. Imagine you have your data organized into a line like this. 25% represents the first quartile, 50% represents the second quartile, and 75% represents the third quartile. So if anyone is talking about quartiles, that's really what they're talking about. They're just talking about these three different percentile rankings. And that's it for this lecture. Understand what percentiles are, what quartiles are, and what percent.
Measures of central tendency are values that describe the middle, or central, characteristics of a set of data. Some terms that may be used to describe the center of a group of scores are the most common score, known as the mode, the typical score and associated with the 50th percentile, known as the median, and the average score, known as the mean. As you can see in the figure, in a normal curve, the mean, median, and mode will be the same. This is not the case when data is skewed, as seen by the negatively skewed and positively skewed figures. The next slide will show you how to find the mean, median, and mode of a data set by using the descriptive statistics function in Excel.
In this video, I will demonstrate how to use the descriptive statistics tool. This tool computes basic descriptive statistics for a set of data, such as the mean, median, mode, and the standard deviation, among others. So in this example, we have some data on height of a group of individuals, height in inches. And so we want to develop some descriptive statistics for this data. So the first thing we want to do is go to the Data tab and select the Data Analysis option, which is going to be on the far right. Now, if you haven't downloaded the Data Analysis tool, I have a video that demonstrates how to download and how to activate the Data Analysis tool within Excel. So we want to click that option, and then in your dialog box here you want to find Descriptive Statistics, highlight that, and then click OK. And then the first thing we need to do is indicate the range of data that we want to include. So I'm going to click the Ref Edit button, and we want to make sure we highlight the name of the data, the column label, as well as the data itself. So I want to highlight that, and then either click Enter or click the Ref Edit button. And I want to make sure I have the box clicked that labels in first row, so it will actually label the output box for me. Okay, and then the next thing I need to do is choose the output range. So I want to indicate where I want the table to be placed that's going to include my results. And I can click Enter or the Ref Edit button to do that. And then I want to click the box labeled Summary Statistics, and if you'd like to have the confidence intervals for the mean, you can click that box. If you want to have the largest and smallest value and so forth, so you have several options there you can choose. Once that's done, we click the OK button, and now we have our data output, and we can go ahead and adjust the cells here so we can see the label for each of the pieces of data that we've been given. So here we see the mean value for our data set, the standard error, the median, the mode, the standard deviation, the variance, the skewness score, and lots of other pieces of information that can be utilized for us. And then we also here have the confidence, 95% confidence intervals.
Let's review.